Hi, everyone. Welcome to the VMware Cloud and AWS Expert Office Hours. My name is Asaf Lupstein, and I'm a Customer Success Architect for the VMware Cloud and AWS team. And with me is my colleague from Italy, Fabio Real, who is also a VMware Cloud and AWS Customer Success Architect. In our session today, we're going to talk about design guides for deploying and having a successful deployment for VMware Cloud on AWS environments and SDDCs, and basically several guidelines of what other design elements we need to take into account when we have an SDDC in our environment. The first thing we want to do is just, we have a couple of poll questions for you. So the first thing we want to ask is, how familiar is everyone with VMware Cloud and AWS? And we have a poll for that now. We will wait a couple, about 30 seconds for everyone to answer so we can get started. Just in the meantime, just a quick review of our agenda. We're going to talk about some networking considerations, security guidelines. Mostly we're talking about networking security here. Storage and compute, availability and recoverability. And of course, if you have any questions, please feel free to use the Q&A panel. Okay, so just a review of the poll. We have about half of our participants currently using VMware Cloud on AWS in production, so that's great to hear. And about 25% that are currently evaluating VMware Cloud and AWS in their environment. So please, if you have any questions about how to operate it and integrate it into your environment, feel free to ask us in the chat. And another 25% that are planning to use VMware Cloud and AWS. Okay, so I think we can continue to the networking section. And we have one other poll question regarding networking. This is a very quick question. So if you are currently using AWS, either native or with VMware Cloud and AWS, are you currently using a Transit VPC model? Okay, so we have quite a mix. Some that are using it, some that are not using it, and some that are not sure what a Transit VPC is. So I will hand it over to Fabio to cover the SDDC groups and then also the Transit VPC model.
Thanks, Asaf, and thanks everyone for joining our Expert Office Hour. So today I will just give you an overview about the SDDC grouping and what is the Transit VPC. So I will give you just a few more insights on what we are doing with our customer and how that could help you to speed up the usage of your VMC platform. So starting from the version 1.11, we have announced that it's possible now to just create an SDDC group. That will mean that you can interconnect two different SDDC within your organization, allowing a fast speed connectivity with lowest latency. In the past, it was only possible to create a connectivity using a VPN, so there was just several constraints on that related to speed and latency. But we have announced that now you can use the Transit Connect that will create an SDDC group. So that means that if you got into your organization multiple SDDC, say you got one dedicated for several applications, another one for test and dev or whatever, you can interconnect all your SDDCs within your organization with just the Transit Connect that is that will leverage the Transit Gateway from AWS, but managed by us. So you don't need to take care about all the configuration. You don't need to do any kind of just on-deep configuration on the connectivity. VMware will take care about that and will establish all the connectivity between your SDDCs. So that will mean that you will reach and you can share everything between your SDDC on a fast speed line. So everything will flow on that Transit Connect. You can manage the security on that, so you will be able to ensure that all the traffic is still secure, allowing only what is needed. Everything will be announced within that Transit Connect, and that will help you a lot. Also, if you just have also a direct connect and a direct connect, sorry, pairing that to your Transit Connect. So that will mean with a single line, you will connect your to SDDC or multiple SDDC within your on-prem using your actual direct connect. So let's see a little bit about that, and let's see on the next slide how it works. So actually, you see, we got just our org with multiple SDDC. So everything is just split inside your SDDC. So every SDDC, it's just designed to be a single data center that live just alone. But generally, our customer need to interconnect those SDDC to ensure that all the applications are able to talk and are able just to just deliver the service to the customer, to the end customer. So with that, with the Transit Connect, we are improving the way on all the SDDC are interconnected and how you can expose all the services to your final customer or just to your internal customer. So we can just move forward. Okay, so what will happen is that we are going to create with the Transit Connect, so with the SDDC grouping, we are going to deploy a transit gateway that interconnects the two different SDDC. That will mean that we are using just the native transit gateway from AWS, and we are changing that just to allow you to only manage the routing if needed and the security policies. So this design will allow to interconnect also the native AWS VPC to that transit connect that will allow you just to do a peering that where you can consume all the native services, and you can also connect a direct connect gateway, a DX gateway to your Transit Connect to ensure that you are connecting, that you're reaching your on-prem fast and with just high availability and with low latency. That will help you to scale out and improve the overall experience of your internal user and external customer. So if we can move forward a little bit. So with the Transit VPC, it's a new design, a new concept that we have announced 3 weeks ago. So with the 1.15 release, we are playing a new way to just use the Transit Connect and to improve the availability. So a lot of customers are reaching us asking, can I just manage the routing table when I'm using native AWS services? Can I manage better the traffic when I'm just using the Transit Connect? We need just to route everything into a security VPC. How we can do that? So with that Transit VPC, we are just giving to you the opportunity to better manage all the traffic that is flowing outside of VMC and to manage the routing, to manage also the possibility to connect different SDDC in different org. So within the same region, that is the actual constraint, you can connect different organizations. So in the past, there was not possible because one of the limitations of the Transit Connect was just the organization. So you were not allowed to interconnect SDDC that belong to just different organizations. Now you are just able on doing that. So the Transit VPC is just an empty container from AWS that will be created into your AWS account that will allow you to better manage all the routing and all the traffic. So you can go on the next slide with the schema. So what will happen is that instead of connecting your direct connect gateway or just everything directly on your VTGW on the Transit Connect, we will establish a single connectivity from the Transit Connect to the Transit VPC. So one of the most important use cases is just the usage of the security VPC. So we got several customers that has deployed a firewall, have deployed their just security layer on the native AWS, and you need just to reach that security VPC in the right way, and you need just to route the traffic properly. So you will be able on doing that using just the Transit VPC connectivity. That will allow you to just send all the traffic across the VPC, and that will just give you the opportunity to manage everything. So the Transit VPC, it's just a container. It's just a VPC that you are going to create into your AWS account. So the VPC is just a logical container when you can define just networking, where you can just deploy services or whatever. So in that case, we're just using a VPC with multiple elastic network interface, and you can just manage all the routing on that VPC. That will mean that you got all the control, you got full control on your traffic. The security VPC, it's one of the most important use cases. So that in case that you're going to deploy a firewall, or you want to manage your traffic or just send the traffic across multiple app link, I don't know, a direct connect, a VeloCloud Edge, or multiple VPNs, you can manage everything inside that Transit VPC. So if you can just move forward on the next slide. So that is just another usage. So in the past, to reach a native AWS transit gateway, the only way was just use multiple VPNs and maybe use the equal cost multipathing on the VPNs, but there was a limit on the bandwidth. With the Transit VPC, we can use just the Amazon, the data center, the Amazon data center backplane on the networking. So you will have a high bandwidth connectivity also to your AWS native transit gateway. So you will send all the traffic on your transit gateway, and you will be able to reach everything that is delivered by Amazon without the need of a VPN. So that will improve your stability and your speed. So that is another great use cases from our customer. So if you can just move forward with the slides. So another just opportunity is just to interconnect SDDC from different organizations. So we got customers that are maybe big companies, so they got multiple org, and they'll need a way to interconnect all the SDDC group in a better way than a VPN, because that was the only way. Up per today, you can do that with the Transit VPC. So the only constraint is that you must be, so all the SDDC must be on the same region. So that is the biggest constraint. So it's not possible to interconnect SDDC from different region, but you will be able to interconnect SDDC from different org that are deployed on the same region. So that will help a lot the communication and will improve the scalability of the systems. So that is just what is the Transit VPC, and if you got any question on that, feel free to ask. Just a note that is already on GA. So if you are looking to use that, it's already available on all the customer. You need just to reach your CSM or your CSA to ask for the feature to get enabled. So it's available, but it's not enabled by default on all the SDDC. So just feel free to reach your CSM or your CSA if you need that feature enabled, and we will help you on that. So Asaf, I will give it back to you on the multi-edges.
Thank you. So I think one of the things that Fabio mentioned was, especially for the TGW, for example, connectivity using VPN, that there is a limitation with bandwidth occasionally. And we see that sometimes with customers that have very large SDDCs or even require different traffic patterns that can be very bandwidth consuming, that occasionally we need to start scaling the edges. And in version 1.10, we have introduced the concept of the large edge, which does allow for much higher bandwidth and a lot more packets per second. However, sometimes even that was something that we needed to scale for different reasons. One of the features that we introduced in VMware Cloud on AWS is multi-edge SDDCs, or basically allowing to deploy multiple tier 0 edges in the SDDC to provide better north-south, or I shouldn't say better, but more bandwidth for north-south traffic. There are several types of traffic that this can be implemented on, and that is traffic to the VMware Transit Connect that Fabio just mentioned, and traffic to the connected VPC. So these are things that and traffic types that we've seen a lot, either between SDDCs or to native AWS VPCs, but also, for example, the connected VPCs, where there's a lot of backup traffic that can be, for example, separated from the main traffic to make sure that we don't miss backup windows, and also we don't have any impact for all of a sudden weekly fulls of databases that will impact user traffic. So this is something that manually needs to be enabled and also manually steered, so you can control which connectivity is using which edge, using traffic groups. And that is something that is leveraging source-based routing. So you do need to make sure that it's what segments or IP ranges. You can be very flexible with that. Within your SDDCs will use that specific edge. So we can move to the next slide. So as we mentioned, it increases network capacity for certain traffic types. And what we will do is we will deploy another set of active and passive edges, and leveraging compute policies, we will make sure that edges are running on separate hosts. So that way there won't be any resource contention or network contention between the default edge and the new tier 0, or even any other tier 0 that you're adding. I believe that you can add multiple tier 0s and multiple multi-edges if you want to steer traffic in multiple directions, or separate it even more. And you just need to make sure that there are enough hosts in the cluster, in cluster 1 specifically, to run those additional edges. And you can go to the next slide. Okay, so some of the requirements is that the SDDCs need to be in 112 or higher. That should be the majority of customers that are running M12. And any new deployment right now is running 114, so should be good there. We can only steer traffic to other edges if we are leveraging the Transit Connect or the connected VPC. Any other type of traffic, for example, internet traffic, VPN, NAT traffic, that will still leverage the default tier 0. One other requirement is that we have to have a large SDDC, so a large edge already configured. We cannot have multiple medium edges. And of course, as we are deploying a second pair of edges, we need to make sure that we have at least 2 hosts per traffic group plus 2 for the default edge. So for example, if I want to run 2 traffic group, which is 2 extra pairs of multi-edges, I will need 6 hosts total in cluster 1. And of course, this is something that is just best practice with resource management. For the NSX edges, while they do have reservations on cluster 1, we still need to make sure that we're not overwhelming those ESX hosts with a lot of resource intensive VMs that are running on the same host as the edges, to make sure that there won't be any impact there. So ideally, cluster 1, if possible, will only be used as a management cluster, where the rest of the VMs will run on separate clusters, if possible. If not, just we need to make sure that we don't run VMs on those specific edges. Okay, and I believe we can move to the next slide. So the traffic pattern here, and this is pretty much the same traffic pattern, whether it's going to a connected VPC or to a native VPC in AWS. The reason we chose this diagram is to show both incoming traffic and outgoing traffic between 2 SDDCs leveraging the VTGW. So we can configure multiple prefixes and multiple site arranges, and even individual VMs if we want, or workloads to route using a different edge. And we can see, for example, if we have traffic going from traffic group 1 on the left SDDC to traffic group 1 in the right SDDC, it will leverage the new scaled edge, or the new traffic group edge, and all traffic between these two segments will leverage outbound will always use the new edge, and inbound, it just depends on their destination. If they will communicate with a VM that is not part of that traffic group, it will go to the default edge, and if it is, it will go to the new scaled edge. There is one question in the chat, so I will answer that live. Are there any charges associated with inter SDDC traffic? There is cost with that is we don't upcharge for any traffic cost outside. It's the same as any AWS egress charges. But between SDDCs, if they leverage, for example, the VTGW, the cost there is the same as any native TGW cost for attachment and gig processed by that specific region. I think most regions are 5 cents a gig, if I'm not mistaken, but it's something that we can send you the link to those pricing. So for security, we have another poll for you about your current firewall policy, either on-prem or on cloud. So take about 30 seconds for those. The options are, if you're only using a perimeter firewalling, are you using specifically in VMC gateway firewalls only, and either on-prem or in the cloud if you're using the distributed firewall or microsegmentation. Okay, so I see we have pretty good vision there. About 40% of participants are using distributed firewall and microsegmentation, which is great. And the rest are using either perimeter firewall or gateway firewall only. So just very quickly, this is something that we want to cover with our networking security practices and how it works in VMC. If we can to the next slide. Okay, so in VMware Cloud on AWS, we have multiple gateway firewalls. As we also have two tier ones, we have the compute gateway, which connects to all of the workloads, and the management gateway that controls access to our management VMs and the ESX hosts. So each one of those tier one routers also has a gateway firewall of their own that controls connectivity to these specific workloads. The important thing is that this controls only north-south traffic from workloads that are behind that tier one router to workloads or any destinations outside of that tier one router. So for example, if I have multiple segments connected to my CGW, let's say, for example, 192.168.1.0 and 198.162.2.0, the CGW firewall doesn't control any traffic between those two segments. So this is really connectivity from any outside environment, whether it's native AWS and another SDDC or your on-prem environment. This is where that is being controlled. However, the gateway firewall does not control any traffic between segments that are connected directly to it. Okay, and the management gateway is very important to control access to your vCenter NSX environment, SRM, if you have it, and HCX. One thing that we want to mention is, I don't know if several of you that have VMware Cloud on AWS in production, we've noticed, and one of the security enhancements we want is just to raise awareness, the fact that this is still access to a vCenter and still access to manage your entire environment. So we have launched right now, if you have the source for your vCenter configured as any, you will get either an email notification, or there's also going to be a banner on the SDDC itself letting you know that you have a rule that provides unrestricted access to your vCenter. So this is still something that while we manage the vCenter and all of the management workloads, it is still something that the owner of the SDDC needs to make sure that access to that vCenter is still controlled, to make sure that we don't have unauthorized access to vCenter. And we can move to the next slide. Okay. The second type of firewall that we have in the SDDC is the distributed firewall, and that is one that really, if you're not familiar with the distributed firewall, the model is that instead of securing an entire segment, for example, because of the distributed model of NSX, we are able to control and basically place a firewall at the VNIC level. So we can control, for example, in this model, even though all the VMs are part of the same IP range, we can still segment within the same layer 2 domain, because we're not bound by layer 3 really, or because we can place the firewall directly at the VM level. This also provides us with a lot of functionality of grouping VMs, not necessarily based on IP alone. You can if you want. You can also group VMs based on VM names, based on tags that you want, to make just the operation of those firewall rules a lot simpler and a lot more dynamic. So for example, instead of specifying the specific IP for any database VM, if I scale this, I can just tag the VM or give it a prefix of DB-01, for example, or 02 and 03. And then we will be able to, it will just be added automatically in the firewall rules. And we can continue to the next slide. So that is one strategy for if you really want to do full microsegmentation. But sometimes this is moving from a completely different model that you haven't implemented on-prem, for example, but you still want to have that separation between different between different network segments, similar to how you would do with a perimeter firewall on-prem, where I just assume that all the traffic in that specific segment can talk to each other, except for when it leaves that specific segment or when it's supposed to pass the firewall. As I mentioned before, within VMC, the compute gateway only controls traffic that either enters the compute gateway or will leave it at a later time. So between those two segments, the gateway firewall doesn't come into place. What you can do to kind of implement the same methodology is using the distributed firewall, however, not in a full-on microsegmentation model. This is something that can be in phase 2 or phase 3 of your adoption of VMware Cloud on AWS. This is really this is a very valid approach and very normal for customers that did not have NSX on-prem, for example. So this is a newer model of security operation. So instead of segregating in a specific VMs via groups or anything like that, you can very easily just configure different the entire segment as a group and create firewalls similar to how you did previously on-prem, to make sure that you can control traffic that way between different segments, if that is a requirement for you. Okay, I think we can move to the next slide. And so now we're going to talk about storage and compute, and I will hand it back to Fabio.
Thanks, Asaf. So let's talk a little bit about just the scalability, how EDRS works, and a little bit also about all the storage policies. So let's talk about the EDRS. So as several of you probably well know, on VMC, we got just not the classic, only the classic DRS, but we got the elastic DRS that will allow you to set several triggers to scale out your data center when that is needed. So what the EDRS will do, it's just taking care about your SDC and scaling out the number of hosts when is needed based on your configuration. So that could be enabled at every cluster level. So for every cluster, you can set up a different EDRS policy. So that will allow you to set maybe just a cluster with a more aggressive policy that will just add hosts before then maybe another cluster that don't have a EDRS policy or just have a less aggressive policy. So the system is monitoring every 5 minutes the usage of your host, looking to CPU, memory, and storage. Just a thing that cannot be changed, it's just the policy related to the storage. So when using just the EDRS, there is just by default configuration that is for the storage only, that is the default one, that will kick in an host when you will just cross the 75% of used storage. That policy is enabled by default and cannot be changed. So the trigger for the slack space, so that means that you will need to have at least the 25% of space that is free at every time, that cannot be changed by you. So that is part of just our monitoring and our management. So after that, the EDRS will help you to scale out, and just keep in mind that when a new host will be added, you are going to pay on demand for that host until you create a new subscription. So just be careful when using the EDRS. So if we can move forward on the next slide. Okay, so that is how it works. So the EDRS, it's just monitoring your cluster utilization. So when the threshold will be reached, the system will automatically add a new host, and your capacity will be increased for your workloads. So the system, it's also able to remove the host if needed, but that will happen only when you reduce really a lot the usage on your cluster. So on our website, there are all the specifications about the triggers, but keep in mind that we are not going to remove the host just after that is just reduce by, I don't know, 5% your storage consumed or just your computer sources used. So that will be generally all of our customers are just removing manually the host if needed, because it will require longer for the EDRS or maybe for your workload to just reduce the number of resources that are used. So we can move forward on that. Okay. Storage policies, I will just give back to Asaf to talk about that.
Thank you. So as you may know, the underlying storage platform in VMware Cloud and AWS is vSAN. And an important part of vSAN is storage policies, where you can have the flexibility of configuring a specific RAID or availability policy per VM or per group of VMs, and not for the entire cluster. So you do have the flexibility of configuring your own policies. We also have that feature that was introduced in 1.12, I believe, as well, the managed storage policies that will automatically adjust the policy of each individual cluster the default one, depending on the number of hosts. The reason that we have it depending on the number of hosts is to maintain SLA compliance. So this does not mean that it's not going to be supported, but just if it's compliant with the SLA that we provide for each SDDC size, and that is something that we can place in the chat later, our SLA document for VMware Cloud on AWS. So if we have less than 6 hosts in an individual cluster, and remember, this is something that you can mix. You can have one cluster of more than 6 hosts and then another cluster in the same SDDC with 6 hosts or more. We are required to maintain at a minimum an FTT of 1. So that means that once we have one failure, we'll be able to recover from that. And by default, the policy will have it as RAID 1. However, if you want, and if you have the minimum number of hosts, which is 4, you can have configure your own RAID 1 as well. RAID 5, and it will be compliant. Once the cluster expands to 6 hosts or more, it's because of the size of the cluster. To maintain SLA, we require an FTT of 2. So by default, the managed storage policies will change the policy to RAID 6. However, if you do have, for example, specific performance requirements on certain database workloads, for example, you can still maintain them as a RAID 1 with an FTT of 2, as long as, it's just a capacity exercise of how much we're going to, what is going to be the RAID overhead there. We do also require a slack space of 25% for each cluster, and this is where EDRS comes into play. There was a question about that before, and Fabio mentioned that. By default, we always have EDRS working for the storage threshold to make sure that we can maintain proper vSAN operations, such as if we're required to do any rebuilds or resyncs, or even if you want to, if you're required to change your storage policy. There is also a different SLA requirement for stretch clusters that I can cover, that I will cover later. We can go to the next slide. Okay. So one other thing of compute that a lot of times we see that being used on-prem is DRS affinity rules. So for example, creating an anti-affinity rules if you have two domain controllers, for example, for your Active Directory environment. You don't want them to run on the same host in case that host reboots and then your entire environment is not, domain controllers are not available for a certain amount of time. Or sometimes you want to keep things together or bind VMs to specific hosts, things like that. Because of the permission model in VMC, Cloud Admin, the user that you are provided, does not have access to DRS. You cannot change the DRS policies. You cannot change, and because of that, you cannot create affinity rules. One of the solution that we came up for is compute policies. So compute policies work in a very similar manner, but actually, what I like about it more than just traditional DRS rules, they function using tags. So you don't have to necessarily go and manually add a VM to a group and remove a VM to a group. You configure a policy based on VMs with this tag cannot reside on the same host, or VMs with this tag cannot reside on hosts with these tags. And then all you need to do is just manage the tags on the VMs, either via VRA, for example, or ParCLI or Terraform, whatever you use to maintain tagging on your virtual machines, and then basically achieve the same feature set that you can with DRS affinity rules. So we have 3 types of compute policies, which are VM to VM affinity, VM to VM anti-affinity, or VM to host anti-affinity. And one other one that is very specific and unique and to VMware Cloud on AWS, which is disable DRS vMotion. So for example, DRS is enabled in VMC, so we can load balance your workloads. However, if you have a virtual machine that is very sensitive to any type of network network blips, even if it's the vMotion, for example, that is very, it's about less than a ping, but some workloads might have an issue there. So you can disable DRS vMotion. Now, this doesn't mean that we will never vMotion that VM, because, for example, when we perform upgrades for the SDDC, we do need to restart the host to upgrade the vSphere version. So that VM will only be moved in case of the host going into maintenance mode, whether it's proactive maintenance or as part of the lifecycle upgrade. And we can move to the next slide. And one other thing that is important when you design your SDDC or you bring in a new workload is custom CPU core count. This is a feature that we have enabled in VMC for a long time, where basically it allows us to limit the number of CPUs at a hardware level that are exposed to a specific ESX host. So you're still getting the same CPU, for example, whether it's an i3 or i3En, but let's say with an i3, instead of getting 18 cores per CPU, so 36 cores in total, you can have 8 cores per CPU, which will give you 16 cores total. At first it sounds like, why do I want to have less cores? But for certain applications that require licensing based on the number of physical cores that you have, and a lot of times they require licensing the entire cluster, not just the virtual machine itself, then this will really help you to save down on licensing costs, to really have a separate cluster, for example, of 3 hosts with custom core counts that will be dedicated to that specific application, and maybe some of it supporting VMs as well, but it will really help you bring down those licensing costs for that application that sometimes kind of outweigh the need to have more cores for that specific cluster. One reminder, this can only be done on additional clusters. So we cannot do it on cluster 1 because we have NSX and vCenter, HCX, SRM, all of those management VMs running there, and we really cannot limit the core count for those virtual machines. And I can move to the next slide. And for this one, we have one poll do quickly as well to just verify if you are running your workloads in VMware Cloud on AWS, how are you currently protecting your workloads? Are you performing any type of DR, backup, both? And we can talk about those strategies overall and in a bit. Okay, and I see that about 60% are protecting using disaster recovery and backup, about 15% doing backup only. No one is doing DR only so far, and about 25% are don't have DR or backup, and we'll discuss those strategies in a bit. And to you, Fabio.
Thanks, Asaf. So starting to talk about just backup and disaster recovery, we'll talk about a little bit about the responsibility when using the cloud. So if we can go on the next slide. So these metrics show how we are sharing the responsibility across VMC. So where you'll need to what you need to take care about, what VMware is taking care about, and what AWS is doing for us. So looking just to the first part of the graph, so of the metrics, it's showed up what you need to take care. So first of all, you need to take care about your own data. So VMware is not backing up anything related to your data. So we are not backing up your VMs. We are not taking care about your data. So you need to take care about your own data, like what you're doing on your on-prem side, using a backup solution, just taking out the data on a different place and ensuring that you can restore everything from your own backup solution. Then you didn't need to take care about just antivirus, firewalling. So Zaf has just shared with us a lot of good information related to the firewalling. You need to just take care about the authentication and everything else. Look into VMware, we are taking care about your SDDC. So we are taking care about everything that is management components. So we are taking care about the ESXi platform. We are taking care about vCenter, NSX, HCX. So everything that will run over the bare metal that Amazon is giving to us. So we are taking care about the management stack. Then AWS, it's just taking care about all the hardware. So we are taking about just the host. So physically, the hosts are placed into an AWS data center. So they're taking care about the hardware. They're taking care about the network backplane and everything that is related to the physical infrastructure. So that means that you need to just back up your data and ensure that everything is stored safely also on a secondary place. So that's really important because we are not doing that. We are only backing up just the vCenter configuration and a NSX configuration. So in case of a whole availability zone will be just lost, we can just restore the vCenter components, but we are not going to restore anything that is related to your data. So we are only managing just our components and the management components. So if we can go on the next slide. So just a little bit of how it works. So we are managing and we are checking the hardware and working with Amazon to ensure that at any time you are just running on hosts that are just working perfectly, that they don't have any failure or whatever. That will mean that if we got also just a predicted failure that is just notified on one host, we are going to remove that host and ensure that the new host will be delivered to you. So that is what we are doing. So we are just monitoring everything. So we are just thinking that you got just the correct configuration, look into the SLA. So that's why it's really important to take care about the storage policy. So that will ensure that in case of multiple failure, you're not losing any data. So that's a reason why you will receive mail if you are out of compliance. Your CSA will reach to you just to ensure that at any time you are just into the right configuration to ensure that you're not losing any data potentially. So again, up to you, Asaf, for the backup strategies and a bit more.
Okay, so we can go to the next slide. And before we talk about backup strategies, as Fabio mentioned, we maintain availability within an availability zone. However, an availability zone is still a physical location. It's still a data center or a collection of data center that sometimes make up an availability zone. However, while it's uncommon, things happen in a data center. There's things that can take down an availability zone once in a while, and that is something that if you want to make sure that you have that regional availability, and this is something that is very important because there have been instances that an entire region lost connectivity. We can maintain using stretch clusters availability across two availability zones. So this does bring up one important thing that will lead to the next slide. This is not a recoverability strategy. This does not provide backup. If, for example, one VM we perform synchronous backup. So if one VM, for example, at the application level, something is being deleted or if something gets corrupted, it will immediately replicate to the other side because that is just storage level replication. So on top of the availability strategies that we have both built into the SDDC, or if you choose to also implement a stretch cluster, we have some recoverability strategies that we recommend that you perform to make sure that you protect your workloads. And if we can go to the next slide. So the main one is just, as Fabio mentioned, we can't back up the data, right? We don't back up the workload data. We protect it at an availability level from vSAN's perspective. However, if something happens at the application level, you need to make sure that you have the availability to restore that, the ability to restore that if that's something that in your internal SLA is required. So this is not a specific backup solution, and I've just, I'll place that on for backup products. I have just placed the HCL link specifically for backup products that have been validated on VMware Cloud and AWS. So contact your specific backup vendor if there's any type for the specific configuration that you're required. But this is just kind of a proposed architecture that we have in a very high level, but leveraging, for example, the connected VPC and a dedicated backup traffic group. So for example, all of the backup traffic from that proxy server within the SDDC will be sent over through a dedicated edge to make sure that it doesn't impact any workload traffic, and will also flow to a caching mechanism, or some backup vendors have a front end for their own file system that in this case will just go to an S3 bucket. That's a lot of backup vendors have that, leveraging AWS's native resources. But this way, for example, backup traffic does not incur any cost, because there's no cost to the dedicated ENI or the XENI for the connected VPC. We just have the cost of the storage and the backup manager. But this can be very different from different backup vendors. The proxy can reside in the connected VPC, or the backup manager can reside in the SDDC. There's different specifics. The important thing is just having a strategy to back up your workloads if you have a requirement for that. Because if there's something catastrophic happens in the application, or this is not something that we can recover from because we don't have visibility to your applications. And we can continue to the next slide. So I will cover, and you can finish building the rest of the slide there. We also have, in case of recoverability, using backup is great, and sometimes it's enough depending on your internal SLA. However, in case of not only a region failure or region, an entire region being unavailable, but also this is a very valid security strategy right now. DR is an extremely important component of ransomware, for example, and security validation, malware, etc., to make sure that you have the ability to spin up an environment in a different region that is isolated completely from your existing production environment. So we have two solutions that, depending on your specific requirement, will not dive deep into those. That can be covered in another session if there's any interest there. But our first strategy is VMware Cloud Disaster Recovery, which allows to spin kind of on-demand SDDCs, or just pilot light SDDCs, where the majority of storage resides in a scale-out file system, and then hosts are spun up as needed. And our second strategy second offering is, if we can up to the next slide, is leveraging VMware Cloud Disaster Recovery, or DR as a service, which will leverage SRM that does provide some faster RTO, because we have, and if we can move to the next slide. That does provide some faster RTO because the data is already replicated to vSAN and spun up. The workload has an immediately the performance that is required for running directly on vSAN and not on a scale-out file system. But we do have two solutions. You can work either with your CSM or your CSA or your solution architects to find the best solution for your environment. Okay. And if we can move to the next slide, we do have one pre-submitted question. And that is best practices for HCX connectivity. And will we deep dive that in a future session? Yeah, HCX is a major part of VMware Cloud and AWS and your cloud journey. And that is definitely something that we will cover in future sessions to both connectivity options and migration strategies. Okay. And if there are any other questions, feel free to post them in the chat. Fabio and I will stay a bit over. And also, we do have a couple of poll questions just to provide feedback about this session, about any topics that you want to see in the future. So please, if you can answer those polls and let us know what you want to hear about next in the chat. Okay, and if you're required, you have several extra resources that we can have. The Cloud Tech Zone has a lot of, let's say, bite-sized information and reference architectures that you can leverage that have walkthroughs and different design that will really complement our traditional documentation. Of course, the customer success community, where it's both customer success architects and customer success managers. If you have any questions about billing and subscriptions on top of technical questions, we're all there. And of course, the VMware Cloud on AWS homepage that has a lot more information about pricing and ingress costs and things like that. And if you need to reach out to us, have Fabio and myself's email, my Twitter. We are also on LinkedIn. Well, as I mentioned, if there's any questions, we will stay for a couple more minutes to answer any questions or discuss anything else that you may want to talk about. So thank you very much for attending.